Okay, good morning, everyone. Thanks for your coming. So today, first I'm going to finish this chapter, and then we move on to the next chapter in which we are going to talk about economic growth. All right. So raise your hand if you cannot hear me. So make sure so you can hear me clearly. So these slides kind of summarize where we live in last class. Right. So in the current chapter, so our target is to measuring GDP. We start with nominal GDP, even without specifically explain that, right? So essentially, so we just look at GDP by look at the market value, right, of the goods and service we produced in the current year. Okay, so that's nominal GDP. And then just remind yourself, there are three different ways to calculate GDP. And make sure you understand those three different approach. They should give you the same number. Right? So nominal GDP, and then so later we look at real GDP. So the difference between nominal GDP and real GDP lies in the facts. So which price are we going to use to calculate GDP? And why that matters? Last class, I give you a simple example. Think about an economy produce 3 apples versus 2 pears, right? And then sorry, 3 apples and 3 pears versus 2 apples and 3 pears. Okay. Now the question is how we are going to compare these two economies. In the sense how we are going to add apples with pears. So that's why we need to look at the price of apple and the pear, and then we calculate the market value of the goods and service. Here is apple versus pear that we produce. Okay, and then so we can compare. Okay, so nominal GDP essentially use the current price, and real GDP, what do we use? We use a particular year as a base year, and then we stick with that price to calculate GDP. So that's nominal versus real. Okay. And we also mentioned the change dollar. So this is in case, so if you move from year A to year B, so to different year, depending on which year you use as base year, you end up with different growth rate for GDP. So dealing with these complications, we use chain rule. So basically, first you use A as base year to find a growth rate from A to B. And the next, you use B as base year to find a growth rate from A to B. And then, so you take an average of this growth rate versus this growth rate. So that's what we call it, change dollar. All right, so the last things we discussed in last class is aggregate price level, right? So what's aggregate price level? Is a measure of overall price in the economy. So we first need to define a market basket, and then so we keep track of the cost of this market basket. By keep tracking of this market basket cost, we find a measure of price level, right? And we have looked in these examples, okay? So I'm going to skip these examples. Now let's see, so what was the last things we left? So we talked about inflation. So if inflation essentially is the percentage change in price index. So look at this formula. So price index in year 2 minus price index in year 1. So that's change in price index divided by the price index in year 1. So that's going to give you the percentage change. So delta means change. Percentage change in price index. Right. So this is inflation. Okay. So we have a look at these examples. Now let's see. Okay. So here just give you an idea. How does this market basket look at in reality? All right, so this is for US economy, this is in 2010. And actually, so this market basket may adjust over time. Why they may adjust over time? It just reflects the households may adjust their consumption patterns, right? So in 2010, so look, housing consists of 41%. And the next big one is food and beverage, right? And after that is transportation, medical care, so on and so forth, right? So you can imagine in 2020, the transportation may reduce because most of the times we stay at home. On the other hand, medical care may increase, right? So in that sense, so these consumption bundle need adjust or need change from time to time to reflect change in consumer pattern so that we can have more precise measure in terms of the price level. Okay. And this just show you so over time, so this price index increase in the US economy overall, this is an increase trend. There's some point like Great Depression, so you see deflation, but most of the time is inflation. And here, so we use 1982 to 1984 as benchmark. So use that year's price index as a baseline to calculate the inflation rate. Right. Okay, so besides consumer price index, we also look at other price index. Here's an example, we look at producers price index. Okay. So what's the difference? Consumer price index, we look at what does typical American households or consumer consume. Producers price index, we look at what does typical business they purchase, right? What's the difference? Households, so they may care about beverage and food, healthcare, transportation. Business may cares about raw material, the price of corn, the price of copper, the price of gold, so on and so forth, right? So that's different. And then why we have two different price index? Because these two price index give us a different gauge or different measure regarding to certain aspect of the economy, right? And beside this, we also have a GDP deflator. What is GDP deflator? So the crude way to understand GDP deflator is that the GDP deflator use all goods and service we produced as a market basket. Maybe I can just draw a picture. Think about this is all the goods and the service we produce. Okay, so that's going to be represented by this big region. Okay? And around this region, part of this we define then as a market basket for households, and we calculate CPI. Oh, apology. Okay, we calculate CPI. And then so we have another bundle we call it PPI. They may overlap each other. But overall, so and then the big one is GDP deflator. So that's a crude way to understand. Right. So in reality, these three things, most of the time they track each other. Right? But certainly, so there are fluctuations different. So GDP deflator is most smooth. Right? And the PPI, which stands for Producers Price Index, is more volatile compared to GDP deflator. Right. All right, so I guess that's it for this chapter. So we may come back if you have time to watch this video. So now let's move to the next chapter, okay, in which we are going to talk about economic growth. Okay. What? Okay, very good. So now it's ready to load. Okay, so what we're going to do in this chapter. Here's a roadmap of this chapter. So essentially, we are trying to understand what does long-run economic growth means, and where does long-run economic growth come from, like the factors that explain why we observe long-run growth rate, and why the long-run growth rate may differs across countries or across region, right? And then lastly, we talk about sustainability of long-run economic growth. This naturally leads to resource and environmental issues, right? So that's the roadmap of this chapter. Now let's look at economic growth. Okay? So economic growth, we have seen that in the introduction. Essentially means the increase in standard of living. And based on previous chapter, essentially means increase in real GDP, right? So let me write down. So it means increase in real GDP. Okay. So typically growth comes with both benefits and a cost. Okay? What is the benefit? As I showed you earlier, growth brings us more variety of goods and higher quantity of goods that you can enjoy or you can consume. What's the cost? The cost is the air pollution. This is just name one out of many. The growth and typically also comes with inequality, right? So that's we need to have a deeper understanding regarding to economic growth. Okay? But first, let's just focus its bright side. Okay? So how does growth brings us prosperity, or what's the benefit of growth? To understand that, let's just first comparing three different countries. Okay, look at their historical experience in terms of economic growth. So this starting from 1900 to 2010. So yes, we can extend the data to today, but this pattern presents, or the pattern persists. Okay. So on the very top, we have United States. And then, so in the middle, so we have India. India, this solid line. And you have this light line, which is China. Okay, what have we seen from here? Few things. Number one, overall, United States is on top of China and India, and pretty much all of the rest of the world. This is number one. And then number two, China and India, they start to experience in higher growth rate after 1970 or 1980. And how we can see that? So essentially, you can see the gap between US and China, or the gap between US and the Indian is narrowing. So this narrowing gap between those countries actually reflects their economic growth. Right. Now here, this example just shows us the notion of economic growth. Suppose real GDP for Micronesia is 200 million in 2010. Furthermore, suppose population is 100,000 in 2010. If population increased to 105, GDP increased by 5, then it must be the true that real GDP per capita in Micronesia in 2011. What happened to that? Okay, so let's write down the information. 2010, 2011. Okay, so here is the real GDP, and clearly this aggregate real GDP is 200 million. And then so in 2011, increased by 5%, so that's going to give you 210 million. Population. The population was 100,000. Now increased to 105,000. The question asks you, what is real GDP? If we look at aggregate GDP, yes, there's a growth. But now if we look at real per capita GDP, so you must use the aggregate divided by the population. Aggregate divided by the population. And then it's going to turns out, so the per capita GDP stay the same, which is $2,000. Okay, the same here is 2,000. Right? Yes, they have growth in aggregate GDP, but this has been exactly offset by increase in population. Right? Hence, the per capita real GDP stay constant. Okay. Now we can look at the growth experience in the United States from 1900 to 2010. Okay? So there are two ways to look at. First, we can normalize 1900 real GDP as 100. Okay, and then so you can find out. So from 1900 to 2010, the GDP increased from 100 to 758, or roughly the GDP has grown by 8-fold. But keep in mind, this is real GDP per capita. On the other hand, so we can use 2010 to normalize the numbers. So 2010 is 100, and then so 1900 is 13. Okay? By comparing these 2 years, also by comparing what happens throughout this time period, so we can clearly see the power of economic growth. Right? And this picture just show you how the growth or how the economy varies across our globe, right? So United States here, or the North American, right? So this is including Canada. And from here, so the higher the income, the darker the color. So that's reflects by this color. The lower the color, the lower the income, right? So there are 2 things you may want to pay attention. Number 1, there's wide range of difference across regions. You have regions very dark, United States, Australia, most West Europe. You have region very light, Africa, South Asia, right? Okay, this is number 1. And then number two, so we need to pay attention. So why this country, so they have higher per capita GDP. And why those other countries, they have lower per capita GDP? What is behind their difference? Right. Okay, so there's a simple rule for us to appreciate the importance of growth. So this is called rule of 70. Okay. So if there's a country grow by certain percentage, say for example X, it's going to take 70 divided by X years to double its economy. Look at the example. If a country grow by 3.5% per year, it's going to take 70 divided by 3.5 years, so which is equal to 20 years to double its GDP. Okay, so this rule of 70 is quite useful. I want to mention, so this rule of 70 is very accurate for a small number of growth rate. Or in other words, when X increase, this rule of 70 becomes less accurate. Okay, because essentially this is an approximation. Okay, now let's look at this practice question. Suppose real GDP per capita grow at 2%. How many years will it take? Okay. And clearly the answer is C, right? Because just use the rule of 70 we just learned. Now another questions. So I give you 1 minute to read, and then so I explain to you how should we solve this problem. In the meantime, I write down all the information we need to answer these questions. Okay, so look at these questions. It says India, the per capita GDP is 3,000. Italy is 24,000. India grow by 5%. It asks take how many years for India to reach the level of Italy. So we need to have 3 steps. Step number 1, first find out the difference. The difference between India and Italy. So that's going to be 24,000 divided by 3,000 is 8 times. And secondly, so you need to find out how many years it takes to double India's GDP. Okay, use the rule of 70. 70 divided by 5%. So that's going to be 14 years. Now the last step. So every 14 years, you double your income. In order to increase income by 8-fold, how many times you need to double your income? So the answer is, so you need to double 3 times, right? Because 2 raised to the power of 3 equal to 8. You need 3 times, so 14 times 3. So that's going to give you 42 years. Right? So the answer is 8. Okay. All right. So now let's look at the recent growth experience across countries. So this is a time period from 1980 to 2013. So we look at a few selected countries. On the far left, we have China. So the growth rate for over 3 decades is close to 8%. And in the middle, we have United States. The growth rate is 1.7%. On the far right, we have Zimbabwe, which has a growth of negative 1.4%. From the rule of 70, we can clearly see over time. So this small difference is going to translate into huge difference, right? So I leave that calculation for you to understand if this pattern persists for 100 years. Okay, if this pattern persists for 100 years, how would that differ? So for example, if you compare China versus the United States or China versus India, how would those countries behave differently in terms of per capita GDP in a 100 years time period? Okay, so for you to appreciate the power of growth, the rule of 70. Okay. Okay, now we look at the second topic, the source of long-run growth. What are crucial, important that give us long-run economic growth? Okay, so we have identified a few things. First is labor. So first, we need to understand labor productivity. Okay? Labor productivity is output per worker, or essentially is real GDP per worker. Okay? So Physical capital. That's going to be important to explain growth. What is physical capital? Physical capital is the human-made resources such as buildings, machines, right? So why physical capital is important? Just think about the farmer, right? Yes, the farmer, they can use their hand to plow the field, or they can use large animals, right? But certainly a tractor is going to way more efficient, way more powerful. So that is the power of physical capital. Okay. Second, human capital. What is human capital? So we come to class, we come to school, we get education. Okay? Or if you have a job, you have on-the-job training. Right? So that's going to make you a better worker or more efficient player. Right? So those are considered as human capital. So essentially, the human capital allows us to produce goods and services in a better and a more efficient way. Okay? So next is technological progress, which is defined as advance in the technical means of production in goods and service. In this background picture, just show you one example that happens 100 years ago. So when the American economy relies on iron and steel, right? So they invent these new ways to refine the iron and steel so that dramatically increase the productivity, right? So now we are ready to understand aggregate production function, which is a hypothetical function that shows the relationship between productivity, which is essentially the real GDP per worker, and the input, which I'll talk about, or the important factors that matters, we just mentioned, including physical capital, human capital, and the state of technology. Right? So this aggregate production function just give up a mapping between those three important inputs and how much we can produce per worker. So this is quite important so that we can understand why one country differs from the other country. It's because one country has better physical capital, or because the country has better human capital, or simply because the country has better technology. Right? So that's going to help us understand what matters and what determines or what explains the cross-country experience, cross-country difference. Okay, so now we want to specify how those things related. Okay, so when I say how things related, essentially how the GDP per worker explicitly depending on physical capital, human capital, and technology. So T here stands for technology. Right? So this is a typical functional form economists find out that capture well the reality. All right. So now let's see. So how does this function behave? Right. So this function has some well-known patterns. These well-known patterns has important economic implications for us to understand the economic growth phenomena. Also, it's important for us to understand economic policy. First, there's a diminishing return to physical capital. Okay. It just says holding the amount of human capital per worker and the state of technology fixed. If you increase the amount of physical capital, that's going to lead to a smaller increase in productivity. What does this mean? It just means if we have the same level of physical capital and technology, if those things are same, now you simply give worker additional physical capital. Think about additional computer, or think about additional delivery truck, or think about additional pen or pencil. So those all are considered capital. And then, so what economy found out is the additional physical capital is going to contribute to the productivity in a smaller and smaller fashion. All right, so this is called diminishing return to physical capital. What is behind that? Think about, so because you have certain amount of attention, right? And also because additional capital may make the workplace crowded, right? So those are potential explanation why we have diminishing return to physical capital. Okay? So this diminishing return to physical capital also has important implication. One implication is that, so the poorer the country, the higher the return of their physical capital. That immediately implies the higher economic growth rate, right? So this slide is going to virtualize the production function we just talked about, right? So let me reproduce the production function we have. Let's use Y to stand for productivity, which is real GDP or real output per worker. Y equal to T times, so capital, that is physical capital, times human capital, right? So this productivity relies on three things: technology, physical capital, human capital. Now, what do we do here? We just fix T, fix H. We want to look at how productivity change with physical capital. And then so we have this concave curve. Okay, so what does concave means? Essentially means, so the curve flatten out. So flatten in the sense the slope of the curve will decrease as you increase physical capital. But what is the slope of this curve? The slope of this curve essentially is additional return in output you can get by incrementally increase your physical capital. So this flattened curve exactly reflects the diminishing return to physical capital in the previous slides, right? Diminishing return to physical capital, right? So that's reflected by this flattening of the curve, right? So as usual, so I'm going to take a 5 minutes break, okay? And then so when we come back, we will continue our discussion regarding to economic growth.